Okay, so on Thursday we learned definition of a derivative, which was the limit definition, and that was kind of a longer way to find derivatives. Today we're going to learn shortcuts. So today is the day where we learn how to do derivatives in a much faster, easier, and more fun way, right? Of course, much more fun than limits. So I'm going to start by giving you 4 rules. But one of the rules we're going to derive. We're going to come up with it on our own. But the first rule we're not. The constant rule. Does anyone know what a constant function looks like? It's a line, but it's not just any line. It's a horizontal line, right? Horizontal line. So if I were to draw a horizontal line. Now this is a tricky kind of a question. How would I draw a line tangent to this line? It would be right on top of it. Because a tangent line just shares the same slope at the point of tangency, right? So you pick any point on this line, and to draw something that shares the same slope would be the same line, right? So what happens is whenever you have a linear function, the tangent line is the same as the line itself. So the line tangent to a horizontal line is the horizontal line. What is the slope anywhere on this function? 0. So what that means is whenever you have a constant function, the slope, no matter what, is always 0. So here's our constant rule. If y is a constant, then the derivative is 0. Right? So no matter what, if y is a constant, the derivative is 0. Alright, we're going to do a little activity to figure out the power rule. If you already know what the power rule is, then don't yell out. Okay. So
yeah, actually I did. That's weird. How am I going to do this?
okay.
Not twins then.
Back there. That's a little better. Yeah, I think that's pretty good. Okay. So x is x. This is the function that I have chosen. In this case, I've chosen the function y equals x. In this column, we have the derivative at that value of x. So what we're going to do is we're going to figure out the derivative of y equals x. So this is our f of x, and this is going to be our f prime. So if f of x is x, anyone figure out what the derivative is of x? It's not 0.
X.
What's the derivative when x is 1?
1.
What's the derivative when x is 2?
1.
What's the derivative when x is 3?
1.
What do you think the derivative is for any value of x?
1.
It is, the derivative is 1. 1. The derivative is 1. So for y equals x, the derivative is 1. Let's try y equals x squared. Alright, so these are my x values. This is just x squared, right? This is the derivative. I wish I could get this a little bit better. That darn glare. Okay. Alright, so anyway, alright, so we have x, we have the function which is x squared, and we have the derivative. in your groups, I want you to take a second and see if you can figure out how to get from your x value to the derivative value. We're just trying to figure out a function for that derivative. So, in your groups.
Multiply by 4, then divide by 2. That's what it is, guys.
Here, you remember.
Multiply by 1,000. Subtract 500. Multiply by 200. Put like a big long
Alright,
equation.
so Nelson says that it's 36x over 18. Is that correct?
Yeah.
Or in other words, 2x. Alright, so if f of x is x squared, then f prime is 2x. Does everyone agree with that? Good. Let's take it up a little notch. Alright, see if you can figure out quietly amongst your groups, see if you can figure out the derivative of x cubed. This one's a little harder. So, talk to each other, see if you can figure it out.
Wait, what? Oh, yeah. I think that's right.
How to get from x to the function that's in y2.
She got that French vanilla. That was my nickname in college. It was a joke, because France, middle school was college, so.
How many groups have it? Raise your hand, I want to see.
At least 6.
Okay, so those of you that don't, you're going to put your hands down. The groups that don't, I'll give you a hint. It's a multiple of x squared.
3x squared.
Where's your hand? He knows it.
Did you guys figure it out? Oh, you said it? Okay. Are there any groups that still don't have it yet? What's the derivative of y equals x cubed? 3x squared. Now, for x to the fourth, quietly, in your, quietly,
Only see x to the fourth.
I want you to look and see if you can determine a little pattern, and then check the numbers and see if they concur with your theory. Or hypothesis.
Let's see. Okay. So they got 1, 2, 2.
Look for a pattern.
Ooh,
See
okay.
if you can think of what it
Maybe
is.
it's 4x.
Adding a 1x
Because it's
something.
so 4 times x.
The numbers support your
No.
hypothesis. They don't?
Yeah. X.
4x to the 3.
4x to the 3. Yeah. 4x to the 3.
Yeah, that's right.
Doesn't have to be 1.
4x.
Isn't it?
No.
Yeah. Bring down the
Yeah,
x.
that's what I'm saying. What's 2 cubed for
Bring
x?
down the x.
I don't know. Oh, it does. Yay.
By 1. 4x.
Alright, what's the derivative of x to the fourth?
4x cubed.
4x cubed. Now, without doing any more numbers, say I asked you for x to the nth. Can anyone figure out? Yes, Taylor.
nx to the n minus 1.
Beautiful. Do you guys all see that?
Yeah.
Good. You just derived the power rule.
I don't know what number n is.
Okay. So, power rule. Okay, so the power rule says if y equals x to the n, then y prime is nx to the n minus 1. So you take the power, you multiply it times the function, and then reduce it by 1. Now, the reason that the power rule is so powerful is because it can be used for x to any power. It doesn't have to be an integer. So if I needed the derivative of the cube root of x, that's just x to what power? The 1/3 power. So, oh my gosh, it's just 1/3 x to the negative 2/3, right? Right. So, anyway, yeah, it works for any power. Say I had 1 over x to the 5th. How would I write 1 over x to the 5th as x to just a power?
X to the 1/5.
No, x to the negative 5th. Negative 5th.
Gotcha.
Negative is what makes those the argument go to the bottom, right? Yeah, so anyway, yeah, it works for any power. Negative exponents, rational exponents, all those different exponents fit in the power rule. So the power rule covers a very huge, vast array of functions. Not all, right? It's not going to help you with ln x, right? But it'll help you with a lot of functions. All right, the constant multiple rule. If y equals c times a function, if there's a constant in front being multiplied, then the derivative, that constant just gets multiplied by the derivative. So coefficients just come along for the ride.
Oh, this kind of reminds me of when we did limits.
Yes, yeah. Very similar. That's the constant multiple rule. A constant multiple is also called a what? When you multiply a function times constant, that constant is called a
Scalar.
scalar. Right? Right? Okay. Are you ready for a joke that combines biology and pre-calculus?
I'm actually so ready right now.
Are you ready?
Right.
Okay. What do you get when you cross a mosquito and a mountain climber? Now I should tell you, a mosquito, does anyone know what a mosquito is called in biology? No? That an invading organism is called a vector. A vector. No one knew that? Really?
Mr. Biden said that.
Oh, okay. Well anyway, so, what do you get when you cross a mosquito and a mountain climber?
Vector scalar. Scalar.
Nothing! You can't cross a vector and a scalar. Oh, get it? Oh, good. Oh,
You also could get malaria.
Okay, some difference. If y is the sum or difference of two functions, then y prime is just the sum or difference of their derivatives.
Right.
Those are all the rules we're learning today. Do you guys notice any rules that you think should be there and aren't?
Multiplication.
A product rule and maybe
Composition rule.
quotient rule and a composition rule, right? Yes. So to find derivatives of products, quotients, and compositions, we're going to do products and quotients this week on Wednesday, because those rules do not work so nicely. So if I have f times g, the derivative is not f prime times g prime.
Oh.
Yeah, I know. So products and quotients we'll learn on Wednesday. Composition, f of g, that's going to be next week, because that gets a little more complicated. All right. So what I'm going to do is I'm going to have you guys in your groups solve 5 problems. I'm going to actually solve one of them for you. And so you're going to do the rest in your groups. So for each of the following, I want you to find dy dx. Turn the camera so it's facing the problems.
Oh no. Look at that, I bit my face.
All right, so. Okay, find dy dx. So, number one, if y equals x to the 7th. Number two, y equals 4x to the 3rd. Number three, y equals the cube root of x. Number four, y equals 4 over x to the 5th. And number five, y equals 5x to the 8th minus 3x to the 4th plus 8x to the 2/3 plus 6x minus the 5th root of x plus 2 over the square root of x minus 0.875.
I got stuck on the math one, I'm sorry.
All right. Now, I'm going to walk you through the second one. Okay? And then you should be able to do all the rest.
Wait,
So-
the first one?
No, I'm going to walk you through the second one. Okay. So the second one says y equals 4x cubed. This is a constant multiple, and this is a power, right? So we have 4 times x cubed. Normally when I do a derivative, if I were to do just the derivative of x cubed, I would think 3, put the power out front, and then reduce it by 1. So you get 3x squared.
Right.
But when there's a number in front, that has to get multiplied by the answer. So what my brain thinks when I'm doing these is I just do power times this number, 12, and then x squared.
Oh.
Okay? So my dy dx for this one would be 12x squared. So just multiply the exponent by whatever's in front, and then reduce that power by 1. So in your groups, take about 5 minutes, see if you can get the other 4 answers. You might have to rewrite a function so that you have x to a power before you take the derivative.
You can't just go ahead.
So the cube root of x, that's x to the...
But work together, talk to each other.
Is that an x to the negative 1?
Yeah. 8 times 5, 40. First one? Okay, well, 2/3 times 8.
This requires good algebra.
Yeah.
What do you give for number
3? 1/3 x to the negative 2/3.
Alright, so for number 3, isn't that cube root of x, isn't that x to the 1?
For what? It's 1/3 x times.
I didn't ask for the answers.
What? Yeah, it's x to the 1/3. Sorry about that, brother.
Oh yeah, because root.
Well, then I got
So what I do then,
No,
1/3
the
minus
cube
1.
root is basically x raised to 1/3.
Yeah, so you have 1/3 of x.
So it's gonna be at 1/3 x. It's gonna be x, which is gonna be x over 3.
So it's 1/3 x.
And then
I just
and
think
then
it's
it's gonna be x to 1/2, which is square root of 1/3.
I didn't think
Square root.
Yeah, treat that as 1/3. So it'd be like
Yes.
1/3 x to the negative 1/3? Yeah. Have you finished the other one yet?
Be negative 5.
2/3 times. What's 2/3 minus 1? Is that negative 1/3? Right? 2/3 times 8 is, well, let's make 8 2/3.
You get negative 5 out of x to the 4th.
That's 24 over 3. What's 24? 22 over 3. Negative 20 over x. So it's just 22 over 3x. Negative 2/3. Yeah, negative 2/3. For 4?
Oh, yeah, x to the 6.
Yeah. Negative 1.
So you guys are the
Negative 1/3 is 6.
these exponents one.
Some in different schools. Why do you look
So
at
if you subtract 1 from 1, you get 0. And anything to 0
It's a constant multiple.
Alright, 0.
is 1.
1. Alright, 1. Shut your mouth. And then minus 1/5. Negative 1/5, right? Alright. Root of x equals x to the 1/2, right? 1/2, that'd be 1/2 x, right? No, that'd be 1/2 x minus 1/2.
8 times 2.
I got
2/3?
plus x to negative 3. No, x to positive.
The derivative of 6x is just 1, right?
Because,
Wait, no, just do x cubed on the x, square root of x on the bottom, so that would equal 1/2 x.
No, wait, it'd be 6.
That's what I think it is.
The derivative of 6x is 6, right?
take away the minus.
No, I would take away the minus. And then you put that all over 2, and then you would just take away the top part, right? Yeah, so it's just x, yeah, it's x to the negative step, you're right.
Yeah, that's why I got
Minus.
It's gotta be n minus 1.
Hey, so what'd you get for, what's 16 over
5 over
20x.
16 over 3x and then
20x, I just got 4.
Okay, 2 more minutes, finish up.
I just got 4 over 5x to the 4th. Alright. And then, wait, we have to finish up. And then minus point, what's that? 0? Alright, so then we don't have to worry about that.
So I subtract that.
Then, wait, alright, how do you subtract x?
Wait, negative 1x, just negative x.
How do you subtract x?
Obviously, you just look at the x
No. When you divide this and subtract, when you subtract them,
Negative
you have to do the same. So then,
I'm not simplifying that.
we got this. And then I'll write it out, because she's talking about
There's a 2
y
right,
equals
and you multiply
5
2 by 1
x
half.
over 8 minus 4 8 x to the
Yeah, I
2/3
think I might have gotten by
6 x minus 5
you have to take the derivative of each one. Like,
Yeah, it's the last one.
it's just a pain. See, I really have like that, but then combine negative 0.8 and 5/6. Something like that.
Is that ready?
So 6 is just 0.
6 over 5.
What's the best one you get?
Yeah, what kind of negative 8.75? What are you gonna do?
5.
Go to the meeting. Actually, no, I'm gonna go to lunch, and then for when I'm supposed to be lunch, I'm gonna go to
Psychology.
What can I say? My name is.
40x squared.
Maybe.
What can I say? My name is Bay.
7 minus
That'll never be said again sometime. Wait, what do you prefer? Did do something kind of?
What do you prefer?
That's everything.
Okay, can you tell me each 5 minutes?
Okay,
X to 1.
so here we go. For the first one, if y is x to the 7th, dy dx is
7x to the 6?
7x to the 6th. Any questions on that one?
No.
That one's good. All right, good. So next one, y is the cube root of x. Before we take the derivative, we really need to rewrite this function with just x to a power. So what power would I write for x?
1/3.
Very good, x to the 1/3. In your homework tonight, what you're going to see is a bunch of problems give you kind of a chart where it says function, rewrite, differentiate, rewrite. And what that means is, here's your original function. They want you to rewrite it as x to a power. Then they want you to take the derivative. What's the derivative of this? Then they want you to take the derivative, 1/3 x to the negative 2/3. And then they want you to rewrite that back into radical form. Okay? Because you're going to have to be able to go back and forth between exponents and radicals, or you are going to be lost on differentiating all these different functions, right? You have to be able to go back and forth easily. So if we give you a function in radical form, you better be able to convert it to exponential, or you're not going to be able to take the derivative, right? So you've got to be able to go back and forth. So when we convert this back, what does the negative do?
Bottom.
Just puts it on the bottom. The negative puts the x on the bottom. Is that negative attached to the 3 or just the x? Just the x. So the 3 stays on the bottom, the x goes to the bottom. The top number, that's your power. The bottom number is your root. So this is 1 over 3 times the cube root of x squared. The top number is your power, the bottom number is your root.
That'd be complicated.
Alright, so the negative puts it on the bottom, top number's the power, bottom number's the root. Have to be able to go back and forth. Alright, if you thought that the derivative of 4 over x to the 5th is 4 over 5x to the 4th,
You're done.
that was a really good try, but do you think it's correct? No, because of the tone of my voice, right? Okay. Yeah. No, it's not. Because if I rewrote this as x to a power, I would have 4x to what? The negative 5th. So my dy dx that I know is correct gives me what for an answer?
Negative